Welcome back. In this session, we will have a look at interesting circular economy case studies around the world, using a variety of systems, such as insect farming, industrial symbiosis, and electronic waste recycling. The first case study brings us to Indonesia, where we look at the promising organic waste treatment technology, using insects, and in our case the black soldier fly larvae. Organic waste is fed to the black soldier fly larvae growing on the waste, then we harvest the larvae, and we can obtain a protein-rich product. The leftover waste, or residue, can be further processed to compost, reducing the total amount of waste. The simple BSF larvae process can be scaled to treat up to 10 tons of waste per day. At a treatment capacity of 10 ton per day, about 400 kilograms per day of BSF larvae can be produced. The larvae can then be converted to about 100 kilograms of dried larvae. Dried larvae can then be further processed to about 64 kilograms larvae meal, and 27 kilograms larvae oil per day. The leftover waste after growing the larvae, or residue, is about 2.5 tons per day. 4.5 tons per day of waste is separated in the pre-processing step. The total operation reduces the waste by about 30%. A research project, named Forward, conducted by the Swiss Federal Institute of Aquatic Science and Technology, developed a viable process that is simple and low-tech, so it can be applied in Indonesia, but also in similar settings around the world. A pilot plant was successfully operated for several years and handed over to private enterprises. More BSF facilities are now being established across the country. A market study for the local context in Surabaya identified various potential applications for BSF products. The main target market was animal feed for farmed animals, and for domesticated animals, such as birds or ornamental fish. Although the farmed animal market has a higher market value with up to $70 million per month, the domestic animal market in Surabaya was seen as better option for the BSF products to start with. Its market share is about $1 million per month, lower market entry with less regulations, and higher achievable prices per kilogram. This picture shows the various products that were developed and sold on the market for domesticated animals, such as dried larvae, marketed as pop larvae, or larvae meal, as pro meal. The city of Surabaya is using the BSF larvae process to treat municipal organic waste at waste transfer stations and material recovery facilities within the city. It currently operates 197 transfer stations, the red dots, where waste is brought from the households or non-household sources, temporarily stored, and then transported to its final destination. Also, 2 material recovery facilities exist, where organic waste, paper, plastic, glass, and metal are recovered. Using the BSF larvae process at transfer stations and upgrading them to material recovery facilities could drastically increase the amount of waste recycled and organic waste diverted from landfills. Producing high-value products through the BSF larvae could incentivize the transition to a circular economy, leading to a cost reduction or cost recovery of the waste management through the revenue of products. The Forward project developed a step-by-step guide that allows anyone to start a BSF larvae farm at their location, which can be downloaded here. Additionally, a pro-BSF organization supports BSF enterprises and offers both training and technical support. All the links are available in the resources under this video. The next case study brings us to Africa, in the province of the Western Cape in South Africa. The government departments of the Western Cape needed to find ways to stimulate economic growth and create jobs. Unemployment rates were at high levels, reaching 24% in 2011. Additionally, current waste management had a high impact on the environment. The city of Cape Town alone produced about 5,000 to 6,000 tons of waste per day, of which 87% were landfilled. The financial burden of the waste management, combined with the decreasing capacities of landfills, pushed the government to find alternative waste management strategies. It launched the so-called Green Economy Strategy Framework in 2013, which aimed to address these challenges, reducing the environmental impacts, and combining it with sustainable development. To demonstrate the potential of a green economy, the Western Cape government wanted to implement pilot projects on the ground. The government started exchanges with other countries and also with the UK government, especially on the topic of industrial symbiosis. In short, industrial symbiosis aims to foster a network between diverse organizations, promoting exchange of water, energy, material flows, logistics, assets, and expertise between the organizations and achieving beneficial synergies. The school of thought of industrial symbiosis also influences and is linked the concept of circular economy. Since 2005, the UK government has successfully operated a national industrial symbiosis programme. Between 2005 and 2013, the programme enabled businesses in England to divert 47 million tonnes of industrial waste from landfills, reduce carbon emissions by 42 million tonnes, save 60 million tonnes of virgin material, and many more. Based on the success of the NISP programme in England, the Western Cape government adopted it to the local context and launched the WISP programme in 2013, Western Cape Industrial Symbiosis Programme. The programme is delivered by Green Cape and offers free facilitation services to any organizations in the Western Cape to leverage industrial symbiosis. Results over 6 years are encouraging. About 104,900 tonnes of waste were diverted from landfills. Roughly 310,000 GHG emissions were saved. Over 120 million rand financial benefits were generated. And 69 permanent jobs were created in member companies, and more. Among these great achievements, WISP was also the first industrial symbiosis program in Africa. Let's have a look at some of the symbiotic relationships formed between industries in the Western Cape. In the food sector, a company called The Creamery produces ice cream. The production of the ice cream requires egg yolk. However, egg whites are not used and disposed of, which amounts to about 2,500 litres per year. Through the WISP initiative, the creamery got introduced to another company called Sublime Confectionery. It turned out that Sublime Confectionery requires egg whites for the production of confectionaries. Through WISP, both companies started collaborating, and as a result, all egg whites are used and not thrown away anymore. Additionally, a cost savings of $3,000 was achieved for Sublime Confectionaries, and additional sales of $1,460 for the creamery were achieved. A win-win situation for both companies and a successful food waste reduction. In the textile industry, Suzy Products manufactures various textiles. In the process, about 150 tons of textile waste are produced each year, costing the company transport and disposal costs. Through WISP, Suzy Products was introduced to CSK Material Handling, a company that now uses the textile waste in their process to manufacture carpet underlay, for example. This led to cost savings for Suzy Products and the diversion of 150 tons of waste from landfills annually. The success story of WISP led to further initiatives in other South African provinces, as well as countries that followed the lead of this initiative and adapted it to their local conditions. Other programs are now established in Ghana and Mauritius, for example. For our last case study, we change continents and look into an exciting initiative in Belo Horizonte, in Brazil. Belo Horizonte lies in the province of Minas Gerais. The city has a population of about 2.5 million, with a GDP of 88 billion Brazilian reals. Belo Horizonte is considered a progressive city, and has established award-winning policies, such as the right to food in 1993. In this policy, food is considered a human right, not a commodity. The policy led to a reduction of child mortality by 60%, and a reduction of child malnourishment under the age 5 by 75%. Another interesting initiative that was launched in 2008 tackles electronic waste and inclusive capacity development at the same time. Currently, post-use IT equipment, such as laptops, desktop computers, screens, and accessories, are disposed and brought to landfill. On a country scale, Brazil is producing about 700,000 to 1,400,000 tons of e-waste per year. To start tackling this waste problem, the city has launched computer reconditioning centers, CRC. Instead of landfilling post-use IT equipment, it is brought to the CRC centers, where citizens from low-income areas receive extensive training to repair and refurbish the equipment back to full working condition, thus closing the loop. At the same time, people are upskilled and sensitized about waste reduction and reuse. The refurbished equipment is then brought to over 300 digital inclusion sites in the city, which are also operated by the city. At the inclusion sites, locals have free access to computers and internet, and can get training for basic digital literacy. The program was a great success so far, and is still continuing. It became a city priority with annual targets from 2018 to 2021. Since 2008, the following achievements were achieved. 7,000 post-use IT products were restored, such as CPUs, monitors and printers. On average, 15,000 kg of waste were diverted from landfills each year, and up to 165 tons were diverted by the year 2018. Over 10,000 citizens were trained on basic technical skills and environmental issues. This initiative by the city of Belo Horizonte is a great example of how one can solve an electronic waste problem, create a circular economy, while achieving an inclusive environment to upskill people with disadvantaged backgrounds. Let's summarize what we have learned from these exciting case studies. First, we have seen the potential of using insects, specifically bee larvae, to treat organic waste in Surabaya, Indonesia. We saw how simple the process is, and that it can treat up to 10 tons of organic waste per day, and in a large variety of locations. Then, we saw the impact of Africa's first industrial symbiosis program, in the Western Cape. We talked about a first initiative in the UK, the setup of WISP, and some examples of synergies. Finally, we moved over to South America, in Belo Horizonte, Brazil, where we got an idea about the city and its progressive policies. We learned about the impact of the introduction of computer reconditioning centers for electronic waste reconditioning and the upskilling of people from the area. As previously mentioned, do not forget to go through the additional resources available under this video to learn more about these initiatives. We share links to guides, videos and more. Thank you for listening. See you in the next session.